Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our Decades mini-series. In this short clip, we will cover two types of wrinkles and how they, despite the super wide range of applications in the web world, will only show a very tiny range of behaviors. The first type is hygrothermal expansion, which should be of vital interest to product developers and troubleshooters alike. The second is bagginess, which nearly everyone will face at one time or another. I know your time is precious, so let's get started. If there were one thing that my Web 101 students should recall, it is that a wrinkle is not a wrinkle is not a wrinkle. There are about 24 wrinkle subtypes that you may see in your web career. Excerpted from our must-have 750-page Web Handling Handbook is a troubleshooting tree to help guide you to the right wrinkle. It is really super easy once you see how it works. We even have a free internet app, the Wrinkle Troubleshooter by Avid Apps, to guide you as well. Of course, we won't cover all 24 wrinkles here. There's no need, because they are covered in chapter-length detail in our book, as well as in my award-winning and trademark Web 101 class that has been taken by 5,000 students. Instead, here we will just focus on two wrinkle types to illustrate our decades theme of this mini-series. These two examples are expansion wrinkles and the notorious baggy web. Let me first remind you of a bit of physics with regard to constrained expansion. This occurs when the web is in an open web span but wants to get wider. But it can't, because it's easier to buckle than to move or push edges outward. I like to think of this as not being able to push a rope. It will buckle instead, especially if thin. On a winding roll, layers underneath will keep outer layers from moving outward. Thus again, any CD expansion is taken as one or more buckles oriented in the MD instead of moving the edges outward. This expansion comes from a large variety of sources, such as heating and coating. Common sources for this expansion include heat, water, solvents, and very heavy calendaring. Collectively, we call these sources hygrothermal loading because they are all mechanically equivalent despite there being quite different web manufacturing and converting sources. That is one of the beautiful things about science in general and web handling in particular. You don't have to learn different rules for different materials or different processes. Returning to our decades theme, despite the immense range of web types and processes, almost all fall into a narrow range of concerns. At expansions of only 1 part in 1,000, you have few problems. But at expansions of 1 part in 100, you have very few commercially viable products because wrinkling is severe, perhaps to the point of being unrunnable. So, if we add a little too much heat or a little too much moisture, we may first kick off a MD wrinkle somewhere near the center. If we add a bit more, we add perhaps 2 more wrinkles at the quarter points. Add a bit more, and the wrinkles are fully populated, looking something like curtains or corrugated tin roof. Note that there's nothing to be read in the pitch of the spacing. That's because it just reflects web thickness. Thin webs, such as kitchen food wrap, may have a buckling pitch of only a few millimeters, while paper and thicker films might have a pitch of a few centimeters. Really thick webs have a pitch greater than the web's width, so that type of wrinkling is not even possible. Of course, we could say a lot more about potential relief, such as effective spreading, but that is covered in chapter-length detail in my book and my Web 101 course, so we don't need to do that here. Bagginess is the second and last wrinkle type we will cover here in this clip. Bagginess should be of near universal interest because very few people escape it entirely. Most people think of bagginess as a variation of MD tension across the width, or tension profile for short. While this is fine and correct and intuitive, I will offer an alternative definition and test for this purpose. That is, the natural length variation across the width. Baggy lanes are longer than their neighbors, and conversely, tight lanes are shorter. Longer and shorter? You say, how can that possibly be? My Web 101 students and many others will recall the strip test that shows the difference in length that underlies this defect. Review your notes for how to do this. In any case, the range of rejection is remarkably small given the wide range of webs and web machines and web customers. At 2 parts per 10,000 length difference, you have very few problems. On the other hand, at 20 parts per 10,000 length difference, you have very few commercially saleable products. At the tight end might be paper printing, and at the loose end you might have polyethylene garbage bags. Do you see any connections between the two physics illustrated here? The first we already mentioned, in that the range is exceedingly small compared to many other ranges found in web handling. The second is these physics have to do with the dimensions of length and width, fundamental properties in web manufacturing and handling. I hope you have enjoyed this episode on Wrinkles in this Decades mini-series. Stay tuned for next week's show. We will finish this series, for now, by talking about the most important parameter in web handling, and that is economics. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.